If you run a company in a high-liability physical sector like construction or clean energy retrofitting, deploying artificial intelligence carries an immediate, concrete risk. In these fields, a single paperwork error doesn't just lose a lead, it halts a job site, voids a warranty, or incurs severe financial penalties. To solve for operational overhead, the standard tech industry approach involves pointing a single monolithic large language model at your entire business. This assumes a generic AI assistant can read your emails, run your scheduling, and handle your domain-specific field operations through a single interface. Imagine asking one model to dispatch a field crew via live GPS, verify an EPA credential, and calculate an IRA rebate simultaneously. The model breaks. Generic engines lack the internal logic for domain-specific compliance, creating hallucinations that a regulated business cannot survive. This creates a liability trap. Relying on a generalized AI for complex operations attempts to substitute probabilistic text generation for licensed professional judgment. Deploying generic AI into a regulated environment introduces a massive, unmanaged liability to the balance sheet. The alternative is an engineering method that separates routine communication from high-stakes physical data, implemented in the command centers built by Renewable Renegades. They replace the monolithic assistant with a multi-agent microarchitecture. The workload is distributed across dozens of narrow, highly specialized digital workers. We can see how this functions by examining a live case study, the Retrofit IQ system, a clean energy retrofit platform. Retrofit IQ operates as a federated network of exactly 34 distinct agents, each restricted to a single job description and tightly constrained by specific guardrails. By utilizing 34 specific agents instead of one, the architecture isolates generic business logic, like answering emails and booking appointments, away from bespoke domain risks, like calculating electrical panel loads and aging utility rebates. Making AI safe for the field requires abandoning the concept of a superbrain. You have to treat the deployment as a structured, federated digital organization. Building a network this large from scratch would be prohibitively slow. To bypass this, the developers apply the 80-20 redeployment ratio. To understand how Retrofit IQ is assembled, we start with a blank organizational chart and a master inventory of 326 proven pre-built agents. The build begins with the foundational infrastructure layer. This requires pulling secure connectors, API key vaults, and OAuth authenticators to safely wire the system to external software like QuickBooks and CRM platforms. Next is the operational core. This system pulls in a front desk intake agent, site visit schedulers, and invoicing and collections agents to handle the standard velocity of incoming customer data. The final foundational tier manages government interaction and finances. This includes SAM.gov scanners, grant and funding finders, and strict bookkeeping notes. Tallying this baseline reveals that exactly 27 agents are redeployed straight from off-the-shelf stock. This graphic explicitly states that clean energy needs clean operations. It illustrates that solar retrofits and community outreach require organized, secure business infrastructure running silently behind the physical mission before anyone steps foot on a job site. Utilizing these 27 off-the-shelf agents is safe because their tasks are strictly probabilistic. They draft proposals, sort inboxes, and organize schedules. They do not execute physical work or make binding financial decisions. 79% of this complex AI system consists of proven, reusable business pipelines. You never pay to rebuild infrastructure that already works. But standard business plumbing eventually hits a strict operational boundary. Clean energy retrofits involve highly specific, variable data. Funding relies on tracking mass save incentive programs and interpreting disparate state rebate structures that change by geography. Standard pre-trained AI cannot safely calculate the physical load of a residential electrical panel, nor can it accurately interpret live GPS telemetry from a technician's truck. To bridge that gap, the team engineered 7 bespoke agents. These nodes are custom-built to translate physical realities and domain-specific rules into structured data. The first is the Incentive and Rebate Data Agent. It continuously monitors IRA 25C and 25D funding statuses by exact geography, bringing chaotic program changes into a stable database. The second addresses a cash flow problem unique to utility-funded work. The rebate receivables agent ages every incentive payout, automatically chasing the paperwork required to secure working capital while the bank processes the rebate. In the field, the GPS dispatch coordinator reads live technician telemetry and certifications to route trucks, while the energy model verifier stress tests assessment inputs, tying every kilowatt savings claim to a verified source. Rounding out the physical compliance, the electrification load agent pre-checks panel capacity to avoid surprise service upgrades, and the credential agent watches OSHA and EPA expirations to keep crews legally compliant on site. The final custom node is the EJ and Equity Impact Agent. Its sole function is to track exact outcomes, households served and dollars unlocked, specifically within low to moderate income communities. This image shows an impact dashboard. It displays exact quantitative metrics like people served and projects completed, demonstrating how the bespoke agent translates raw community outcome data into a clean, funder-ready operational report. This 21% bespoke layer functions as a translation engine. It converts chaotic, physical world compliance into clean, structured data that the rest of the business software can easily read and process. This architecture forces a critical liability question. If a bespoke agent hallucinates a building code or recommends an incorrect electrical load, who takes the fall? The answer is locked into the constitutional rule of the command center. Agents draft, humans decide. The tasks are strictly separated. The AI network handles all probabilistic work, reading, sorting, drafting, and researching. But that data stops at a hard barrier. Deterministic functions, executing a money transfer, confirming legal status, or finalizing live GPS routing, run as hard code or require human execution. Every agent group reports to a named human supervisor. The estimator approves the numbers. The project manager owns the client updates. The bookkeeper executes the money movement. The agents hand over a clean draft, and the human brings the license and the judgment. The safety of the Retrofit IQ system rests on structural prohibition. The AI is simply denied the authority to take final action. With the baseline, the bespoke layer, and the governance matrix in place, the fully assembled 34-agent system operates seamlessly. A theoretical client lead hits the system and flows instantly through the reusable baseline plumbing, getting sorted, logged, and scheduled. The data then hits the bespoke domain layer, where the custom agents pull the relevant state incentive metrics and pre-check the specific physical compliance requirements. Finally, the processed, verified data packet stops at the human supervisor, waiting for a licensed professional to review the draft and approve the work. Generic AI models break under the weight of real-world liability because they attempt to process both the drafting and the deciding simultaneously. The evolution of enterprise operations depends on building a rigid digital constitution for micro-agents to obey. In high-stakes environments, you never command the machine to run the business. You design a system that handles the friction so humans can safely scale their impact.